So what I've got here is the things that you are actually given on your formula sheet at the end of the year exam. So what you're not given are these formulas that are in this book on page 42. So you've got for rectangular and you've got for triangular, you've got the mean, and you've got the standard deviation. So the mean for rectangular, a plus b upon 2, is pretty logical, because your mean's going to be smack bang in the middle. It's perfectly symmetrical distribution. So remember, your rectangular has got the a and the b, and basically you've got constant probability, so you've got that shape, and so the mean is going to be right down the middle. Make sense? No problem. Standard deviation is a little bit trickier. Those of you who are calc students might like to look up the proof of this, which involves integration. It's outside the range of this course, so I'm not going there. With the triangular, the mean is a plus b plus c over 3. And again, mathematically, that could be a lot of fun. But we're not going to go there. We're just plugging things into the formula. And the standard deviation being a squared plus b squared plus c squared minus ab minus ac minus bc all over 18. Again, there's a lovely proof involving integration of that, which is outside the range of this course. Perhaps for scholarship you would like to look that up and all the rest of it and know it. So that's cool. Now, you are not given these on your formula sheet. So our best guess is that if you have questions on them in the exam, you would actually be given the formula. I don't think you would have to learn them off by heart, but if you're really keen to get excellence, maybe you just do. They're not that hard actually, are they? You could actually remember them. Okay, so we've got formulas and we're chucking them in there. So let's get moving. Number 1. Calculate the mean and standard deviation for each of the random variables x with rectangular distributions as shown. So the first one, there's the hole there and the hole there and the coloured in and the coloured in. And we've got a 10 and an 80. So the mean is a plus b upon 2 is our mean or expected value of x, and our standard deviation of x is going to be b minus a upon the square root of 12. So all we really need to know is a and b, and a and b. So if you go back to page, well, they never really showed you that, did they? The a and the b. But we had that on our formula thing. So basically you've got your a and your b there. Alrighty, so a is 10, b is 80, so we go 10 plus 80 over 2, which is 90 over 2, which equals 45. So does that make sense that the mean is 45? What's the difference between 10 and 45? And the difference between 45 and 80? Okay, so it's smack bang in the middle. There's no rocket science involved there. Okay, so we've done that one. Now the standard deviation, b minus a divided by the square root of 12, so 70 over the square root of 12. Pop that in your calculator. Okay, nice. So that's number 1. You can finish that yourselves. Let's look at number 2. Calculate the mean and standard deviation of a rectangular distribution. F of x equals, we've got 0.02 when it's between 0 and 50, and we've got 0 elsewhere. So what's your A in this case? How would we draw that distribution? Colour in, hollow, arrow, arrow. This is 0. What's this? 50. And what's the height? 0.02. Correct. A equals 0. And B equals 50. So how do we work out the mean? What's the mean?
45.
Try again.
45.
We're on number 2.
Oh, number 2, just.
Can you read the mean off the graph? Smack bang in the middle between 0 and 50? 25. Yeah. Using the formula A plus B upon 2 being the mean, would go 0 plus 50 upon 2, which is 25. Make sense? Yeah. Okay, so then we need the standard deviation. So how do we get the standard deviation of this rectangular distribution? We need to get that formula, which is in the book, which is given to us. So the standard deviation of x equals b minus a over the square root of 12. What is b? 50. What is a? 0 over the square root of 12. So that'll be your standard deviation. Okay? So that's number 1 and 2 done. Number 3. Okay. Calculate the mean and standard deviation of the random variables x for triangular distribution. So here we've got the diagram, like so. That of course would go that way and that way. We have got 2 and 16. That's 0. What is our A, B and C? A equals B equals C equals, what is A? 0. What is B? 16. And what is C? 2. So we've got our A, B and C. So the expected value of x, or the mean of x, equals, for a triangular, A plus B plus C over 3. So 0 plus 16 plus 2 over 3. So 18, 6 3s are 18. So it's 6. We've got the expected value. What else do we have to work out? Standard deviation. So the standard deviation of random variable x equals this lovely formula, a squared plus b squared plus c squared minus ab minus ac minus bc all over 18, which is going to equal a squared is 0, 16 squared plus 2 squared minus AB is nothing, AC is nothing, so these two disappear and that disappears, so I've got minus BC, so minus 16 times 2 all over 18. Make sure you put those brackets in your calculator. Oh, AB and AC, because A is 0. So 0 times 16 is going to be 0, and 0 times 2 is going to be 0, and 0 squared is going to be 0. So just made I was going to run out of room otherwise. Okay, so you pop that in the calculator, so that's number 3A done. So you can do them yourselves, I'm just sort of giving you the idea. So this next one is a little bit different, and the clue there is, what does A equal? 0. What does B equal? 5. And what does C equal? 5. Okay, so that's the trick on that one, that the C and the C and the B are the same. Okay, that's all good.